Hello, Year 10. Hope you enjoyed that lovely test we gave you on Edmodo on forces, which covers the chapter 5a, and you've uploaded onto Edmodo evidence that you've actually done the work. Now we're moving on to 5b, and 5b kicks off in your book, all under page 146 and 147. Now, like I've done before, is here, I've got a little starter for you, and have a look at the screen. And I'll pause the video now and get a piece of paper out and see if you can answer them. And it's something you should have done beforehand way back in year 7, 8 or 9. So pause the video, so you can work them out. Okay, now you pause the video and start it again. These are the answers. The car's travelling at 60 miles per hour, how far it travel in 3 hours, 180 miles. And 30 minutes, you can do 30 miles. The same car's travelling 100 kilometres per hour, how far will they travel in? 2 hours, 200 kilometres, 15 minutes, 25 kilometres. And if a skydiver is falling at 13 meters per second, they travel in 4 seconds, 52 meters. And this is all the stuff that you should have done before. So you can guess now where we're going. This lesson's all about movement and speed. So what I want you to do is be able to explain the difference between distance and displacement. Use the speed equation, including changing units and rearranging the equations, which you started doing in the first bit of the lesson. And then explain the motion in a circle in terms of speed or velocity. And then finally describe an experiment to measure the speed of sound. So this bit we had looked at when we did vectors way back earlier in the year. But to recap on it, I'm going to show you the difference between distance and displacement. So here we go. What students should we have? Oh, God, it's a good point now that I have. I just can't think of a student to use. I'm going to use Max. There you go. Doesn't look anything like Max, but there you go. Here's Max and his house. Nice big house he's got. And what Max is doing is going to travel to school just here. Now, to Max travel to school, he can't go in a straight line. He goes like this. He goes round there, and round there. Travel on like this. Eventually, he arrives at school bang on time, or when he can do again. Anyway, Max then, for example, doesn't walk to school, but hey ho, isn't walk to school now. He could travel, I don't know, let's say he does 780 meters, and that's where he walks to school. Now, that is going to be the distance he travels. But when I bring displacement in, what I'm going to try to do now is bring back to a different color pen and see if it works. Displacement is different because displacement is a vector and it goes in here. Ooh, weird things happen there. So when I do the displacement, which is going to be here, that could be, for example, only 550 meters. Okay, and this is a difference between distance and displacement. Displacement is something, and I'm getting hold of my black pen now, it kills me, is going to be a vector quantity. And your distance is going to be a scalar. Now, to remind you what they are, a scalar only has magnitude, which is a posh word for size, where a vector is going to have now the magnitude again, your magnitude in, but then it has got a direction. Hence, what we did way back in early in the year, here's going to be a vector, and we can say, for example, if I take that point there, that angle there can be, I'm guessing, could be 50 degrees, whatever. It's like a bearing. And that's why it goes in a straight line. And that's the difference between distance and displacement. Distance, scalar, displacement is going to be a vector. We looked at those earlier in the year. Now, with that then, we can start using displacement and also distance to work out speed. And speed comes from the speed equation. Now, the speed equation, which we all know, is speed is simply equal to distance over time. And you've done this before. Where distance is measured in meters, time is measured in seconds. Hence, this pops out with units of meters per second. But you also, trying to find a different color pen, you can get distance measured in kilometers, time measured in hours, which means it then has got new units of kilometers per hour. And these two you can see in the exam. Now, Speed then, because distance is a scalar quantity, speed also pops out as scalar because it's got no direction, because it's using the distance, which is a scalar quantity. Hence, you know about these speed cameras, and there's a lot of funny stories about speed cameras, but speed cameras are nice, bold in yellow, and they make a lot of money for the county council, and apparently been picking up people that have been speeding on the road recently, and it's amazing, ridiculous values of some speeds rather than people have been driving around out on the quiet roads. Anyway, here's got your post. Now, you have a look at your speed camera, you should notice you've got lots and lots and lots here of lines on the road. You can see them just here, can't you? Now, these lines are sometimes spaced out 1 metre apart, and I think they're about 1 metre, but I'm outside and checking them. And what they do in a speed camera is, as a car comes along, it takes a flash just here, and then what it does, takes a second flash about a second or 2 seconds later. And what it does then, it sees how many lines you've been through. Hence what it does then, it works out your distance by having a picture here and a picture there, and divides by the time can be 1 second. And if you're over the speed limit for that road, you get a picture taken of you and you get done by the courts. Now, to show you something quite funny is Top Gear, being Top Gear, tried to work out how fast a car could go to actually stop being recorded by the speed camera. Because you think about it, it goes so fast. When you get the first one taken here, by the time you got your second picture taken a second later, you've gone completely out the grid. So watch this for a laugh. It's a nice little video, this one. Here you go, a Top Gear special.
In the name of scientific endeavour, we tried to see if it was possible to go fast enough to beat a speed camera. We used a Honda Civic Type R, it did 129 miles an hour, and it was still there for the second flash. You might think this thing would be the one to do it in. It wouldn't. It's only a pretend one, 20 miles an hour tops. So we got hold of a faster car. Right then, this should be worth a go. The Mercedes CL55 AMG. At 89 grand, not only does it cost as much as a house, it's nearly as big as one, but it'll still do 60 miles an hour in 4.7 seconds, and it'll cruise all day at 155 as easily as your car will do 30. But will that be enough? Let's find out. Go on then. Well, we've got the pictures back, and here they are, 148 miles an hour, and oh dear, there he is in the first one, and still there in the second one. That isn't fast enough. We're going to have to try and go even faster, and we will do that.
Now, I haven't got time for this video here. You can actually look on YouTube, and you can keep going with that, and you'll find even that higher than that speed the car, well, the Mercedes was going at, it still got recorded by a speed camera. But you think about it, if it goes fast enough, and I can't remember what speed it was, but if you look on YouTube, you'll find there was over 200 miles an hour it was, and eventually managed to get through a speed camera so quickly that they can actually stop being recorded. Now, you ever seen these in the motorway? These are evil. Now, these are average speed cameras. Now, there's a big argument about this because the speed cameras I had before speed at a certain point. Average speed cameras stop people going through slowing down for a speed camera and then suddenly speeding up again. And what they do is go much larger distance. So you find here the distance could be 1 kilometre. And what they do is you go for your first camera here and it starts a clock. Then what it does, it measures your speed again later on, and then it measures you going out through the next speed camera, and then records a different time, but at a 1 kilometre distance further down the motorway. Then what it works out your average speed, because what it does then, it uses the equation of where it gives your total distance, which could be a kilometre, divided by your total time. Okay, and then what this gives you is something called an average speed. It's still got units in meters per second or kilometers per hour, but what it does then, it makes a much larger distance over a total time. These, they argue, are better because it keeps you slower for a longer period of time, and you find these commonly now on the motorway.